Okay, now let's put this all together. So just like the jelly beans, and I'm going to scroll way back here. Okay, just like with the jelly beans, we had this little map where we have a relationship between number of jelly beans, mass of jelly beans, and volume of jelly beans. And we had to go to group in between. So we've learned about now, instead of talking about groups, we're talking about moles. What is the relationship between moles and count? What is the relationship between moles and mass? What is the relationship between moles and volume? We're going to reproduce this relationship right here. Okay, so now we have something that looks very similar to the jelly bean example. So we're going to fill out this map, and this is key. Now, I don't want you to memorize the map. I don't want you to always have to use the map. I want you to look for keywords, and I want you to think, and I want you to problem solve. Because now we're going to be going from mass to count, or count to volume, or volume to mass. And we need to know what relationships do I need to use. So if I have count, how do I know what relationship to use? Well, words I'm going to look for: particle, atom, molecule. If I see any of those words, I know that I need to use Avogadro's number, which is going to be 1 mole equals 6.02 times 10 to the 23rd things. Okay, so if I see particle, atom, molecule, and the word mole, I need to use Avogadro's number. If I see the words mass, gram, kilogram, units for mass are the word mass. The relationship I'm going to need to use is molar mass. So 1 mole equals the we'll just say molar mass of the substance. And that you have to calculate with your periodic table. So I'll put that here. Calculate with the periodic table. And remember, we're going 2 past the decimal only. We are not going 3 past the decimal because we never need that many digits, and you're just putting yourself in a situation where you could make more mistakes. All right, volume. What are we looking for? We're looking for volume. We're looking for liters. We're looking for milliliters. We're looking for STP. Any of those terms, I am now going to use molar volume, which is 1 mole equals 22.4 liters for gases only. You cannot use this for liquids. Okay, so now I have another map, just like that jelly bean map, that I can use to go from one unit to another. Now, just like the Hartford Hub or the group of jelly beans, the mole is in the center. When we get to mole, we can go from any unit to any unit. That's the hub. That's what we want to get to. Now, here's some problem-solving strategies. When you're completing these types of problems, I'm not going to tell you whether I need to do 1 conversion, 2 conversions. I'm not going to tell you which conversions to use. That is part of what you need to figure out. And so the map that we just completed, so up here, is just an organizational tool, okay? But other things you should ask yourself: how many times is mole mentioned in the problem? If it's mentioned once, we're only going to use 1 conversion factor. If it's not mentioned at all, we're going to use 2 and have to go to mole in between. What are the key words? So if it's atom, molecule, particle, it's Avogadro's number. Mass, gram, kilogram, molar mass. Volume, liter, milliliter, STP, molar volume. Then you're going to set up your problem using train tracks, because that helps you with: where do I put the units? Do I multiply or do I divide? So you're always going to start with the number and unit given in the problem, put it over 1. Bring the given unit down, desired unit on top. Do the units first. Then fill in the conversion factors. For now, we are always going to have a 1 next to mole, and then we just keep on going until we get the unit we want. Now, I'm going to do 3 examples. the first example and the second example have questions there, have the questions to ask when you're problem solving. The last one does not. If you get stuck, come back to here, or come back to the map. But I want you to try and think it through so that you can figure out what units do I need to use and what conversions. Okay, first example, how many molecules of oxygen gas occupy 12.5 liters? So how many times is mole mentioned? 0. It's not mentioned at all. So which means I need 2 conversions. So I either need to use molar volume, molar mass, or Avogadro's number. Now we're going to circle the key words. So we're looking for units. Molecule is one, liter is the other. Okay, so those units are going to tell us what conversions to use. Underline the number and unit given. All right, well, underline the unit, 12.5 liters. That's my starting point. That's what I'm going to put over 1. Now, what conversions am I going to need to use? Because it says molecules, I'm going to have to use Avogadro's number. And because it says liter, I'm going to have to use molar volume. That's it. I don't need a molar mass. I don't need to know even that we're dealing with oxygen. I just need to know that it's a gas and it's at STP. But I don't need to get that molar mass because Avogadro's number and molar volume are independent of identity. Now I'm ready to set up my train tracks. So I'm going to start with 12.5 liters, and I'm going to put it over 1. I'm going to draw my line. I'm going to put this one here. And now the first thing I'm going to do is bring the unit down, liters. And then where do I need to go? So if I need 2 conversions, I'm always going to go to mole in between. Okay, I have to go to that hub. The hub is the mole. We're going to put a 1 next to mole because that's what we're doing. Okay, which means there's only one other spot to put a number. That other spot is next to liter. If the unit is liter, it's got to be 22.4. Now my unit liter can cancel. If I stop here, I'm at the unit of mole. I don't want to be at the unit of mole. I want to be at molecules. So I need to do 1 more conversion, which means mole is going to come down. And then molecule goes to the top. We're going to put a 1 next to mole. And then we're going to put Avogadro's number next to molecule because that is the conversion factor that matches molecules. So 6.02 times 10. And I need my exponent to the 23rd. Unit of mole cancels. Multiply across the top. Multiply across the bottom. Divide top by bottom. And I get an answer of, I just need to flip my page here, 3.36 times 10 to the 23rd. And don't forget our unit is molecules. Okay, now please write your scientific notation this way, the times 10 to the 23rd. Do not put the E there. So it's going to be 12.5 times Avogadro's number, hit equals, divide by 22.4. And then that is our final answer. Okay, another example. What is the mass of 5.50 times 10 to the 23rd molecules of NH3? So how many times is mole mentioned? 0, which means we need 2 conversions. So now we need to look at the problem and look at the units. Mass, molecule. Those are the 2 units that are going to give us the keys, give us the clue as to what conversion factor to use. And then I'm going to underline the number and unit given in the problem because that's our starting point. If I see mass, I need to use molar mass. Molar mass of what? Of the NH3. And remember, to get that molar mass, it's going to be 1, because we have 1 nitrogen, times 14.01. Then I add that to 3 times the mass of hydrogen, which is 3.01, and I get 17.04. That is the relationship that I'm going to need to use, and this unit is grams per mole, to get from mole to mass, mass to mole. Now, the other unit I see is molecule. That's going to be Avogadro's number. All right, now I'm ready to set up my train tracks. So I start with the number and unit given in the problem. So 5.50 times 10 to the 23rd molecules. Put it over 1. Draw my line. And we're going to draw it down. First thing you do, the unit molecule comes down. Bring the units first. Now, because we need 2 conversions, I need to go to mole in between. That's my hub. 1 is going to go next to mole, and then 6.02 times 10 to the 23rd goes on the bottom. That is the conversion factor I need to get from molecules to moles. Then I cancel, and I continue on. Okay, if I stop here, I'm at the unit of mole. That's not where I want to be. I want to be at the unit of mass. So I need to keep going until I get the unit I want. So I need to do one more conversion factor. Mole is going to come down, and then mass comes to the top. Mole, remember we're putting a unit of 1 next to mole, and the mass, I have to put 17.04. Oh, I didn't put the unit of mass, I put the unit of grams. Whoops. That's the mass that I am going to use to get from mole to mass. So now my moles cancels, and I am ready to do the math. And this is the one, if you don't know how to use your calculator, you're going to get the answer wrong. If you get anything times 10 to the 47, 10 to the 46, you're going to get it wrong, okay? So make sure that you have this whole thing in parentheses, or hit the second comma on your TI to get that E button, or use the 10X button. And the answer you should get is 15.6 grams. If you don't get that answer, you get something different, it means you're having issues with your calculator. Okay? All right, I'm going to do one more example. And notice this doesn't have the questions here, but I'm still going to kind of go through it. Okay? How many times is mole mentioned? Well, it's mentioned once. It's right here. So therefore, I only need 1 conversion. So then the question is do I need molar mass, molar volume, or Avogadro's number? Well, then I look. Oh, it says volume, it says STP. So because it has volume and STP, the key word is 1 mole is 22.4 liters. Those words tell us that we need to use molar volume. And we're only going to have to do 1 conversion, moles to liters. So start with number and unit given in the problem. 1.50 moles. Put it over 1. We draw our line. It doesn't need to be that long because we have 1 conversion. Mole comes down, and then the unit liter comes to the top. 22.4 goes next to liter, and 1 goes next to mole. Now you see each time I'm putting the units first, then the number fits in. My units cancel, and then I am left with liters. And so the answer I get is 33.6 liters. So now what I want you to do is problems 1, 2, all the way to 16. So you have time hopefully to work on this in class, get this done, and this, what you don't finish, is homework for the next time we meet. If you have questions, you can go back and watch the video. If you need to, go back and use the map as well. If you're at mass and you need to get to count, then convert to moles first, then convert using Avogadro's number. This can tell you what you need to follow. So good luck.